Hello, ladies and gentlemen. What if I told you there was a way to find trigonometric ratios without using your calculator? Well, I'm about to blow your mind. We're going to talk about the unit circle today. Alright, Mac is probably going to join me at multiple points, so if you hear her, I apologize. Like even right now, she's trying to get up here. So, today we're going to talk about just one thing, and that one thing is this mathematical tool called the unit circle. And the unit circle, hi Mac, is the way that we can find simple trig ratios without using a calculator. Alright, it's a really cool thing, it's a really cool tool or construct, but it sometimes does take a little bit to understand. So we're going to spend all of today going over what the unit circle is and how to use it. So the unit circle is a circle with radius 1. That's why it's called the unit circle, because the radius of the circle is 1. So a circle with radius 1 that can be used to calculate exact values of trig ratios. So that can be used to calculate exact values of trig ratios. So when we use a calculator to find our trigonometric ratios, we get decimals, and sometimes we get irrational decimals, so decimals that keep repeating and don't end. So we want to find a different way to find them that's going to give us exact values, by which I mean fraction values of these trig ratios, so that we can write them and say, all right, we know that this is the exact value, we haven't rounded it at all since it's a decimal. So I'm going to show you 3 different constructs, because these 3 constructs are the basis of the unit circle. Right, if you look on the back of the sheet, you can get a preview of sort of what we're going for, what the unit circle looks like. So I'm going to give you 3 triangles, because the whole unit circle is based on these 3 triangles. The idea of the unit circle is that we start at the origin and we draw a radius of 1, so a radius of length 1. And we're going to take that radius of length 1, imagine if it's like on a string, and we're going to rotate it all around the circle. All right, starting right here, the x-axis, the positive x-axis, is considered to be 0 degrees for the unit circle. So we start at 0 degrees and we rotate all the way around until we get to 360 degrees. All right, so we're going to be able to use that idea of taking this one unit and rotating it all the way around, and we're going to use 3 reference angles to talk about what our coordinate points are going to be. So first we're going to use a 30-degree reference angle. And these reference angles are always going to be measured from the horizontal, from the x-axis. We're not measuring from the y-axis because that would be 60 degrees. This is 30 degrees. All right, and we're going to make a unit triangle. All right, a unit triangle is a triangle with the hypotenuse length 1. So it's a right triangle, hypotenuse length 1, and here we have a reference angle of 30 degrees for our unit triangle. All right, what we want to find is we want to find this point. That's going to be a point on the outside edge of our unit circle. All right, that point on the outside edge of the unit circle is one of those points that we're going to get if we rotate that unit all the way around this axis. So we've got to figure out what this coordinate point is when we have a 1 side length at a 30-degree angle. Well, we know about right triangles that are 30, 60, 90 triangles. We know this is 90, so we know that that angle up there is a 60-degree angle. And we know that we have the ratio x to x. So our hypotenuse is double of what the short leg is. Well, that means that if our hypotenuse is 1, our short leg is half of that, 1/2. And I'm going to use all fractions and no decimals this section. So 1/2. And we knew, because of 30, 60, 90 triangles, that if the short leg is x, the long leg is x root 3. If the short leg is 1/2, the long leg is 1/2 root 3. I'm going to call that root 3 over 2. which is the same as 1/2 root 3. All right, so now we know the coordinates of this point, right? The x coordinate is how far over we go, which is root 3 over 2, and the y coordinate is how far up we go, which is 1/2. So this coordinate has, or this point has coordinates root 3 over 2, comma 1/2. All right. The cool thing about the unit circle is we can use it to find trigonometric ratios very easily. Because if we wanted to ask ourselves, what is the sine of 30 degrees? Hi, Kat. Please don't. What is the sine of 30 degrees? We would say, okay, the sine of this triangle is going to be the opposite side over the hypotenuse, because sine is opposite over hypotenuse. And that would be 1/2 over 1. You might already see where I'm going with this. Anytime we find sine, it's going to be our opposite over 1 because our hypotenuse is 1. So 1/2 divided by 1 is 1/2. So the sine of 30 degrees is 1/2. We can do the same thing with cosine. All right, so if we ask ourselves, what's the cosine of 30 degrees? We see that that is going to be adjacent over hypotenuse. The adjacent side is root 3 over 2. Over 1, right? Root 3 over 2 over 1 is just root 3 over 2. All right, so in a calculator, that would be an irrational decimal, but in fraction form, we can see it's just the square root of 3 over 2. All right, we're going to kind of go faster now as we kind of pick up speed and understand what's going on. We're going to call this a quadrant 1 reference angle. Our angle is in quadrant 1. If you don't remember the quadrants, they go 1, 2, 3, 4. Okay, so those are the quadrants of our graph. So this is an angle in quadrant 1. What happens, because we're going to make a circle that goes all the way around, what's going to happen when we make that circle into quadrant 2? Let's try that. So over here, we're going to make a quadrant 2 reference angle of 30 degrees, okay? My reference angle, remember, is going to be measured from the horizontal, okay? So I'm going to measure, here's my horizontal, 30 degrees up from that is my reference angle. And so I'm going to make my triangle here. I know that this is a unit circle, so it has hypotenuse 1. I can reuse these coordinates over here. We've got hypotenuse 1, we've got opposite side 1/2, and we've got adjacent side square root of 3 over 2. Except for one difference. Because this coordinate point is on the quadrant 2, my x coordinate is negative. So this here is negative square root of 3 over 2, and my coordinates of my coordinate point are negative square root of 3 over 2, comma 1/2. All right, so 1/2 is still positive because we went up to a positive y, but we had to go to the left to get our x value, so that's negative. That pattern between quadrant 1 and quadrant 2 is going to be significant for us. So I'm going to write that pattern over here. So in quadrant 1, our coordinates are always positive, positive. So I'm going to write positive, positive. In quadrant 2, all of the coordinate points will be negative x, positive y. So negative, positive. All right, we're going to continue that with quadrant 3 and quadrant 4 as we go here, but this is a significant pattern to help us with the unit circle. Down here, we're going to shift focus and we're going to talk about a 45-degree unit triangle. So I'm going to make a 45-degree unit triangle in quadrant 1 because we always want to start by talking about quadrant 1. So here's a unit of 1. All right, my point is out here on the unit circle. I'm going to make that unit triangle. And it's got a reference angle of 45 degrees. All right, so what we're trying to find is we're trying to find the coordinates of this point on the unit circle that we're going to get when we go all the way around. So I remember my ratios. Remember that if we have a 45, 45, 90 triangle, we have x, x, and x square roots of 2, okay? So if this side is x and this side is x, our hypotenuse is x root 2. Let's use some quick algebra to figure that out. So if our hypotenuse is 1, then 1 is equal to x root 2. This is going to help us to find what our side lengths are. So let's find x. We'll divide both sides by root 2. And so we get 1 over the square root of 2 is x. But of course, we can't keep it like that because we need to make sure our denominator is rationalized. So we're going to multiply by the square root of 2 over the square root of 2. And so we get the square root of 2 over regular 2 equals x. Okay? That means that this side is the square root of 2 over 2. And my horizontal side is the square root of 2 over 2. Okay? If you don't believe me, try that in the Pythagorean theorem. It'll all work in there. So the coordinates of this point are square root of 2 over 2, comma, square root of 2 over 2. And if we look to find the sine and the cosine of this angle, we can say the sine of 45 degrees is going to be opposite over hypotenuse. We're going to be dividing by 1 again. So square root of 2 over 2 divided by 1 is just the square root of 2 over 2. Makes that very easy to calculate. The cosine of 45 degrees is going to be the adjacent over the hypotenuse. So again, the square root of 2 over 2 over 1. So just the square root of 2 over 2. Okay? So coming down, or over actually, let's do a reference angle. We did one in quadrant 2. Let's use a reference angle in quadrant 3 and talk about what happens with that. So in like a 45-degree reference angle, remember we're measuring from the horizontal. So there's our 45-degree reference angle in quadrant 3. And I'm going to make that triangle. We'll find out what this coordinate point is. So we know that our unit circle means that our hypotenuse is always 1. And then we can just use the same coordinates from over here. So the square root of 2 over 2 and the square root of 2 over 2. But of course, we're in quadrant 3. So this point down here has a negative x coordinate and a negative y coordinate. So this point is negative root 2 over 2 and negative root 2 over 2. All right, and that's going to be the pattern that we see with all of the points in quadrant number 3. Let's write that up here. So our quadrant 3 points have negative, negative. Okay, and then finally we'll use a 60-degree reference triangle, unit triangle, to show the rest. So down here we'll draw a 60-degree unit triangle in quadrant 1. All right, so we're measuring from the horizontal, so here's a 60-degree. All right, and then I'll put that leg down here. We know it's a unit triangle. It's got a hypotenuse of 1 because it's part of the radius of that circle that goes all the way around. And we can kind of reuse our quadrant or our measurements from the top one up here because this is a 30, 60, 90 triangle. So if a 30, 60, 90 triangle has a hypotenuse of 1, it has a short leg of 1/2, and that means it has a long leg of 1/2 root 3 or square root of 3 over 2, which is the same thing as 1/2 root 3. So if we're finding then the coordinates of this point, we're going to say that that's x coordinate 1/2, y coordinate square root of 3 over 2. And if we wanted to find sine and cosine here, we could say that the sine of 60 degrees is equal to the opposite over the hypotenuse, square root of 3 over 2 over 1, which is just the square root of 3 over 2. The cosine of 60 degrees is going to be the adjacent over the hypotenuse, so that's going to be 1/2 over 1, or just 1/2. So no calculators necessary there. And we will try to put a reference angle here in quadrant 4 because we haven't used quadrant 4 yet. So let's put a 60-degree reference angle. Again, remember, we're always measuring from the horizontal. So a 60-degree reference angle is being measured from the horizontal. So there's our 60-degree angle. All right, it's going down from the horizontal. And it's got a radius of 1 or a hypotenuse of 1. And here's our triangle. Okay, so that's not a very good 60-degree angle, but we know our ratios. So if this is a ratio of 1, we can kind of use these coordinates to help us also. Then we know that the short leg is 1/2 and the long leg is the square root of 3 over 2. But of course, it's in quadrant 4, which means that our x coordinate is positive, but our y coordinate is negative. So our y coordinate is negative root 3 over 2. Just as a little aside here, my hypotenuse is never negative. So even if my hypotenuse is in one of these other quadrants, it's always a positive 1 because the hypotenuse is just a distance measurement. It's a measurement of the distance. So it's always going to be a positive 1, even if the other coordinates are negatives. So this coordinate point down here is x is 1/2, y is negative root 3 over 2. All right, and we can say that that pattern is going to be true for any triangle that we draw in quadrant number 4. It's going to have a positive x and a negative y. So coming up here, we're going to say, all right, quadrant 4 has a positive x and a negative y. All right, and before we move on here, there's just a few other things that I want to show you about these other reference triangles that we've drawn. So quadrant 2, it's a reference triangle that is 30 degrees from the horizontal in quadrant 2. But when we make our unit circle, we start our unit or our degree measurements from this line right here. This is 0 degrees. And we're going to go 0 degrees, we're going to go up, 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 up. Here's 90 degrees, straight up and down. And then we're going to keep going, and we can tell that we've gone 60 more degrees here, because otherwise there's 30 in this 90-degree block. So this angle that's being measured by the reference triangle I've drawn is a 90 plus 60 or 150 degree angle. And we can use that to calculate the sine and cosine of 150. So we can say the sine of 150 degrees is opposite over hypotenuse, 1/2 over 1, or just 1/2. The cosine of 150 degrees is equal to adjacent over hypotenuse, negative square root of 3 over 2 over 1. So negative square root of 3 over 2 is the cosine of 150 degrees. If you put this in decimal form and then you try this in your calculator, you'll get the same answer. All right, with a 45-degree unit triangle, the reference angle is 45 from the horizontal, but the actual angle being measured by this line starts at 0. So it'll go all the way from here down to there. And so we're measuring this as a 90, 180 plus 45 more degrees. So 180 plus 45 more degrees there is going to give us a 225, right? 225 degree angle. So then we can say, all right, I have a 225 degree angle here. I want to find the sine of that angle. So the sine of a 225 degree angle is going to be opposite over hypotenuse, so negative root 2 over 2. And the cosine of 225 degrees is going to also be the adjacent over hypotenuse, so negative root 2 over 2 over 1. So negative root 2 over 2. All right, and then finally our last reference angle here. We are again measuring from this line, always going counterclockwise. So measure from this line, starting here at 0 degrees, measuring all the way around to there. So we've gone 90 degrees, 180 degrees, 180 plus 90 is 270 degrees. And then how many more? We haven't gone 60 more. We've gone the other piece of this angle. We've gone 30 more degrees from 270. So we're measuring a 300 degree angle. So if we say what is the sine of 300 degrees, we're going to use opposite over hypotenuse. So that's going to be negative square root of 3 over 2. What is the cosine of 300 degrees? That's going to be adjacent over the hypotenuse, so 1/2 over 1. So 300 degrees is 1/2 over 1, or 1/2. All right, so we're going to use this information, and this is all just kind of background to what we're going to do next. Because what we're going to do next is fill in the unit circle. That way you have it as a reference that you can use for your homework and all the other things that we're going to do in this unit. So go ahead and turn to the next page, and we are going to diagram the unit circle. This is an exercise that students in geometry have been doing for ages and ages and ages and ages and ages, pretty much since the dawn of time. We're going to do the same thing. So we are going to write the angles, and then we're going to write the coordinates of each of the points. So we've got our circle split up here. We're going to start here. notice that there are 2 sets of blanks on each of these angles. We're only going to use the degrees right now. We'll learn about these other ones tomorrow. So we're going to start here, and this could be called 0 degrees, but it could also be called 360 degrees, because if we take this line, we go all the way around the circle, and we come back to the beginning, that's also a 360 degree angle. All right, up here, this is our 30 degree angle. All right, here is our 45 degree reference angle in the middle, and here is our 60 degree angle. All right, and then we know up at the top here is a 90. And then we're going to keep counting. And a few ways to make this easier on yourself is to skip count. So I'm going to skip count by 30s, and I'm going to get all these 30 degrees. So 30 here, we skip this line, 60 degrees, go up to the vertical, that's 90. Another 30 degrees gives us 120. Another 30 degrees, we're skipping this one in the middle because we're splitting this up into thirds. So 120 plus 30 is 150, plus 30 is 180, plus 30 is 210, skip the one in the middle, plus 30 is 240, plus 30 is 270, plus 30 is 300, and then skip the one in the middle, plus 30 is 330. All right, and then we've got the others here that we have to fill in. So halfway between 0 and 90 is 45. We can skip count by that. 45, then 90. 90 plus 45 is 135. 135 plus 45 is 180. 180 plus 45 is 225. 225 plus 45 is 270. 270 plus 45 is 315. And then 315 plus 45 gets us all the way back to 360. So we've got all of our angles in there. Now we have to use all of our coordinates. And we've found the coordinates already on the front. So this isn't going to take us very long because we can just transfer them over. So here at 30 degrees, we found on the front that our coordinate point was the square root of 3 over 2, comma 1/2. Is that right? Yeah, that's right. The square root of 3 over 2, comma 1/2 is going to go in that coordinate point spot right there. All right, and while I'm at it, I'm going to fill in the other 30 degree reference angles. So the next 30 degree reference angle from the horizontal is here at 150 degrees, right? Because if we go from the horizontal, go 30 degrees up, here's 150. I'm going to use the same coordinates, right? But this time, I'm going to the left for my x-coordinate. So my x-coordinate is negative root 3 over 2. And my y-coordinate is 1/2. Still going up to 1/2. In my next 30 degree reference angle, I'm starting at the horizontal and going down 30 degrees. So my next 30 degree reference angle is at 210. And my coordinates are both negative, right? We talked about having a pattern in quadrant 3 where both coordinates are negative. So they're going to be the same coordinates, negative square root of 3 over 2 and negative 1/2 as we've had before. They're just both negative here. And then finally, our last 30 degree reference angle from the horizontal is down here at 330 degrees, right? There's 30 degrees in there. So our coordinates here are going to be positive x, square root of 3 over 2, and negative y, negative 1/2. All right, we're going to do that same thing with our other reference angles. So 45 degrees had a coordinates of square root of 2 over 2 and square root of 2 over 2. Following our pattern, our next 45 degree reference angle is over here at 135, and it's going to have a negative x-coordinate. So negative square root of 2 over 2 and square root of 2 over 2. Our next 45 degree reference angle is down here at 225. You can tell because it's the one in the middle here. And that's going to have two negative coordinates. So negative root 2 over 2 and negative root 2 over 2. And then finally, our last 45 degree reference angle is here at 315. Since it's in quadrant number 4, it's going to have a negative y-coordinate. So positive root 2 over 2 for the x and negative root 2 over 2 for the y. All right, and then finally we'll use our 60 degree reference angles here. So this is going to be our 0.1/2 comma square root of 3 over 2 that we found on the front. Our next 60-degree reference angle is going to have a negative x coordinate, just like these did. So negative 1/2, comma, positive square root of 3 over 2. Our quadrant 3 60-degree reference angle is going to have two negative coordinates. So negative 1/2, negative square root of 3 over 2. And then our quadrant 4 reference angle is going to have a negative y coordinate. So positive 1/2, negative square root of 3 over 2. All right, and then finally all we have left are the 90s. These are actually much easier than maybe you think they are, or maybe you think that they're easy. We remember that the unit circle has a radius of 1. So if we start at the origin and go out 1, we're at a point 1, 0, right? We went over 1 up and down 0. If we start at the origin and go up 1, we're at a coordinate point of 0, 1. We went over 0 but up 1. If we start at this point and go over here to our 1, we're at negative 1, 0. And then if we start at the origin and go down 1, we are at 0, negative 1. So that is the unit circle filled out. Remember this diagram. Continue using this diagram. It's going to be helpful for you. Here are some helpful notes. This is one we already talked about on the front. The x, y coordinates of each point can also be thought of as the cosine, sine of each angle, right? If we're trying to find the cosine of 30 degrees, we're using adjacent over hypotenuse. So adjacent is the x coordinate, square root of 3 over 2, over the hypotenuse of 1. The cosine of 30 degrees is square root of 3 over 2. If we're trying to find the sine of 30 degrees, we're using the opposite, the y coordinate of 1/2 over the hypotenuse of 1. So the sine of 30 degrees is 1/2. You can do that same thing looking at any other part of this triangle. So if we wanted to ask for the sine of 225 degrees, the sine of 225 degrees is just its y coordinate on the unit circle. The sine of 225 degrees is negative root 2 over 2. The cosine of 300 degrees is its x coordinate on the unit circle. So the cosine of 300 degrees is 1/2. Okay? You may have noticed that we're only using cosine and sine so far. To find the tangent of each angle, you're going to divide the y coordinate by the x coordinate, because as you're doing that, you're dividing the opposite, which is the y coordinate, by the adjacent, which is the x coordinate. So to find the tangent of 60 degrees, you'd be dividing the y coordinate, the opposite to the angle, which is square root of 3 over 2, divided by the adjacent, the x coordinate, which is 1/2. So square root of 3 over 2 divided by 1/2 is going to be the tangent of that angle. Okay? We'll do an example of tangent down here. And then the last point here is that the circle can be read forward, backward, or going around multiple times. We've written the circle forward, starting at 0 and going counterclockwise around. We can read it backwards. We could find the angle of negative 30 degrees by starting here at 0 and going backwards 30 degrees. And negative 30 degrees would put us at 330. So if we were asked for the cosine of negative 30 degrees, we would start at 0, go backwards 30 degrees, and find the cosine of this angle, which is its x-coordinate, square root of 3 over 2. Okay? We can go around multiple times if we need to find the, for example, let's see, the sine of 390 degrees. We'll start at 0. We'll go around all the way 360 degrees, and then we have 30 more degrees, so we pop back up here again. And the sine of 390 degrees will be the same as the sine here, so that's going to be 1/2. All right, so we're finding some values here that are not on the circle yet. The cosine of negative 300. So if we start at 0 and we go all the way backwards 300 degrees, where are we going to be? A trick for that is to take 360 and subtract your negative angle. So 360 minus 300 degrees gives you 60 degrees. So negative 300 degrees is the same as positive 60 degrees, right? That makes sense. So if we're asked the cosine of negative 300, we're being asked the cosine of negative 300. The cosine of this angle is its x-coordinate 1/2. So the cosine of negative 300, you can't see that, sorry. The cosine of negative 300 degrees is just 1/2. The tangent of 480, that's more than 360. We need to go around multiple times. So the easiest way to do that is to do 480, subtract 360 to see where we'll fall. So 480 minus 360 is 120. The tangent of 480 is the same as the tangent of 120. So to find tangent, remember we're doing opposite y-coordinate over adjacent x-coordinate. So y-coordinate is the square root of 3 over 2 divided by adjacent x-coordinate, which is negative 1/2. So we've got the square root of 3 over 2 divided by negative 1/2. We know that dividing two fractions is multiplying by the reciprocal. So square root of 3 over 2 times 2 over negative 1. And we can say, all right, the 2's cancel. We have the square root of 3 over negative 1, which is negative square root of 3. So the tangent of 480 degrees is equal to negative square root of 3. And that was a long video, but in return for the long video, you get a short worksheet. So your worksheet's not going to take you very long today. Probably the shortest worksheet I've given out so far. So go ahead and work on that, see if you've got any questions, and let me know. Have a great day.